can extract the bias from my data and from my model, and I can produce a nice, clean, unbiased algorithm that I can use, right? And then I'm done. And then this talk is done. Except it's not that simple. Unfortunately, while tools are definitely necessary, they're not sufficient, because fairness is a process. We need to follow specific best practices. For example, we need to systematically surface risks and hard questions of fairness. We need to resolve them through a process like, what definition of fairness makes sense in the context of our product? And we need to record these decisions and the process that got us there for transparency, and so we can build case studies. And it's important that we do all these things across every single step of the implementation. From defining what ground truth is, to generating labels to train our AI, to actually training an AI that can make predictions. And then importantly, to making decisions and taking actions that are based on those predictions. So, before we can even talk about algorithmic bias, we need to turn our attention to the labels themselves and to whether there's a risk that we have labeling bias. And I'd like to use a really hard example of ground truth here, which is whether a piece of content contains false news. Now, on the one hand, there isn't universal agreement often on what constitutes a piece of false news. Second, at our scale, there simply aren't enough professional fact-checkers in the world. And then three, fact-checking is a process that takes time. So, for these three reasons, earlier last month, we kicked off a new collaborative process to explore new ways to identify more misinformation faster. And one idea is to rely on members of the Facebook community to point to journalistic sources that can either corroborate or contradict the main claim that is being made in a piece of content. This is an example of a signal that could be useful to tell us whether something was misinformation. But now, an immediate concern, of course, is that people might bring their own personal biases, their own personal opinions into this process. And the reason this is a very big deal is that our fairness principle here is that all content should be treated the same, no matter where it comes from. So if, for example, in an extreme case, I told you that all community reviewers are based here in the Bay Area, they would not represent the diversity of the entire Facebook community. So one way we can mitigate this risk is to ensure community reviewers are diverse across things like location and age and gender and ideology. But we didn't think this was enough. So we also built metrics that measure labeler bias in our community review process. These metrics compare how ground truth maps to labels from the community. If there's a gap in how they map for different groups, then we know there is labeling bias. On the other hand, if the curves are nicely aligned and overlapping, then we're confident that we don't have labeling bias and that we are treating all content the same. What we did here, identifying risks and proposing mitigations at the ideation stage, before we build anything, is a very important part of the fairness process. And another very important part is to make sure we're not missing any important risks and to make sure we're not trying to answer all the hard questions on our own. We're currently engaging with external experts, including journalists, third-party fact-checkers, social and political scientists, and legal scholars. Okay. So with this, we've talked about labeling bias. And now I want to move on to an example where labeling bias is not a concern. We're going to address potential bias in the algorithm that learns from those labels and makes predictions. And to do that, I'm going to talk about how, right now, AI and humans are working together to protect the current general elections that are going on in India from election interference. India is a very diverse country with many languages and many regions. And local and community news play a very big role in how people stay informed. Now, as we use AI to fight election interference, it's very important we make sure that that AI is working well across languages and across regions. So one specific way we use AI is to identify civic content that discusses social or political issues. And we want to make sure that we're prioritizing this specific kind of content for human reviews because it tends to be highest risk. And for this purpose, the team built the Civic Content Classifier, which predicts how likely it is a piece of content discusses civic issues. Now, let's look at how it works for different languages. So, the classifier scores a bunch of content according to how likely it is to be civic, or how likely the AI thinks that it is civic. And let's look at how these scores would work for different languages. So imagine that for language 1, although the score is 60%, in reality, only 20% of that content was civic. And imagine that for language 2, 80% of that language was actually civic. And if this was a general pattern across the board, our concern is the AI would be over-predicting for language 1, and it would be under-predicting for language 2. And if we were to use these scores to prioritize human review, we would be wasting resources on language 1, and we would not be investing enough in language 2. And the reason this would be a problem is we need to make sure that every language is getting their fair share of human review resources. All right, so we need to fix this. So one way we can fix this is by making sure that across languages, the predictions the algorithm is making are well calibrated, meaning that the scores map reasonably well to the actual outcome rates. And this here is a beautiful example where if you address the fairness concerns, if you make the system more fair, you actually also make it better and more efficient. Of course, we want to make sure that this calibration holds across all languages and that it also holds across all regions. First, subgroup calibration is a really useful tool for detecting and addressing algorithmic bias. And we've used it internally to study algorithmic bias across over a dozen products powered by AI. And the typical way you can fix miscalibration, if you come across it, is, for example, by making sure that you have enough training data that's high quality and enough high quality labels, to make sure that the distribution of that training data is representative of the kind of data the algorithm will have to predict on in the future. And to make sure that the input features you're feeding your system and the training procedures are adequate. Okay, so we've talked about algorithmic bias now. And let's imagine that we've addressed our bias concerns at the labeling and at the algorithmic stages, and that we have trained an algorithm whose predictions we can trust. We're now going to turn our attention to potential concerns of bias as we take actions based on those predictions. This is what we call intervention bias. And to use a final example here, let's assume we've trained an algorithm to predict whether something was misinformation so that it can take the action of flagging it so we can potentially reduce its distribution. And first, let's look at some hypothetical data here. Imagine that we had a bunch of content and that in reality 30% of it was misinformation. Now, if we had a perfect AI, it would correctly flag all of the misinformation, and it wouldn't make a single mistake where it's accidentally flagging something that was not misinformation. Now I have a question. Did you get the memo this morning? We have not fully solved AI. So as a result, any practical algorithm is going to make some mistakes. It's, for example, going to flag content that isn't misinformation, and it's going to accidentally miss some of the misinformation. And while we cannot get rid of these mistakes completely, what we can do is the following. We can use a slider inside the AI to balance one type of mistake versus the other, depending on how much we care about them relatively. And so, for example, if we said, I cannot accept making any single mistake where I'm flagging something incorrectly, you could move the dial all the way to the left. And yeah, you wouldn't be flagging anything by accident, but then the AI wouldn't be flagging anything at all. So this is not really useful. Now, if you want to take it to the other extreme, you could say it's really important that the AI flags all of the misinformation. So you could push the slider all the way to the max. And if you did that, yeah, it's definitely going to flag all of the misinformation along with absolutely everything else. So that's not a very intelligent AI, right? Okay. In practice, again, the way you set a slider like this is you figure out how costly each type of mistake is. And I want to take a moment to tell you how the slider works under the hood. So the way it works is we make sure the algorithm is producing scores that are well calibrated, like we discussed earlier. And then what we do is we build a decision threshold that we compare against those scores. So if a piece of content, for example, has a predicted score of 40%, sorry, if we set the threshold to 40% is what I meant, and you have a piece of content with a score that's greater than 40%, then it will be flagged. If that score was smaller than 40%, then it will not be flagged. And the reason that it is important to pause for a moment and understand how the slider works is that that slider is how we implement interventions based on predictions. And now we're ready to talk about fairness. So in practice, you can break down content by where it came from, like what language or what region. And if you were to look at the statistics of that content over time, you would find that the ratio of misinformation, for example, per group will fluctuate, right? It'll change over time. And if you took a snapshot and you compared across groups at a given moment in time, you would find that the ratio of misinformation, and of course, if you have an AI that's doing its job, it is going to flag more content from groups that have a higher ratio of misinformation. And that is consistent with our fairness principle here, which is to make sure that we're holding all content to the same standard, no matter where it comes from. And the way we do this in practice, using the slider, is this. We make sure that the scores the algorithm is predicting are well calibrated for all groups. And we make sure that we're using the same decision threshold for all groups. We did also evaluate other fairness criteria based on some of the numbers in those error tables. And the problem is, most of these other criteria force you to use different decision thresholds for different groups. And the problem with this is that if we were to implement this, then we would not be holding content to the same standard across all groups. So that's not what we do. We make sure scores are well calibrated for every subgroup, and we make sure that we're using the same decision threshold across the board. So I've shown you some examples of how we're looking at fairness concerns as we build AI into our products. And some of the key things that we've learned are that we need to surface the hard fairness questions. We need to resolve these questions through a process. And we need to record those decisions and the process itself. And we need to be doing this at every step of the implementation. Now, many of the questions that will arise are hard, and some of them are going to be hard social questions. Therefore, it's essential that the external community is an integral part of this process. And while tools are useful, and in fact necessary, and you should absolutely download and evaluate fairness libraries from GitHub, please remember that they're not sufficient for addressing fairness, because fairness is a process. And now, to talk about hard